Okay, so Ron, thanks for taking the time to talk to me and the people at the University of Waterloo. I know that what we're going to talk about is going to be very valuable to them. Uh, the first thing I wanted to ask you was really just to talk about your involvement in technology based change over the last several years. And I wanted to ask you to give me a brief summary of that.
Okay, thank you, Peter. Thank you for having me. So my baptism into technology integration started in the late 80s when I was working for McDonnell Douglas. There was 10 years of a couple of large machine integrations with McDonnell Douglas, and then there was another 15 years of technology integration with Boeing. So my first experience was I had worked in the oil tooling industry for years, and that industry dried up in Southern California. So I got a job with a company that did chemical milling. And I had never heard of chemical milling, but chemical milling is really big in the aerospace industry, particularly with aluminum primary structure. So I worked there for a couple of years, and I got a lot of good experience. And one of their engineers left and went to McDonnell Douglas, and he called me and he said, look, McDonnell Douglas has just spent like $65 million on this process facility. And he said, they're going to do all this. They got the C-17 program. He says, nobody here knows anything about chemical milling. He said, I went and talked to their planning department, and he said, they think I'm going to do all the work for them. So he recommended that I go and apply, and I did, and I was hired. And I was working there for about 6 months, and then my boss called me in his office, and he said, well, he said, we purchased, or McDonnell Douglas purchased, this CO2 laser, which is going to put on the chem mill patterns, and it's going to save us all kinds of money on tooling. He said, but the only thing we have now is a machine. So the machine was delivered with a machine envelope. There was a group working on some contour boards, because obviously you're going to have to put these in a position, and dial them in so that you can put this pattern on. But they had nothing else. They had no idea how they were going to do it, what they were going to do. So I got into the middle of that, and we had to come up with tooling plans, inspection plans. We had to write process specifications. But it was a perfect example of the old school of machines and machine technology. The thing showed up at the door in a crate, and here's the operating instructions. And so you can get the machine up and running, but now how you have to create a whole process to make things work. So that was my first experience. And then my second experience was a 5-axis CNC mill with a flexible programmable bed that McDonnell Douglas had made an agreement with the Air Force to invest $100 million to improve quality. And naturally, some executives went to Europe, they looked at Airbus, and they decided, oh, well, these are all the machines we're going to buy. So it's kind of like, well, these machines are coming, so you guys have to do something with it. But in order to use this broche automation tool for assembly automation, the product quality of the fuselage skins and the doublers had to be greatly improved. So that's why they purchased this machine. Another thing of nobody's ever used this type of technology in Long Beach. You're going to bring the machine in. You're going to, at least I had some experience on, okay, well, I knew from the planning side of the house what I could do to help plan to get, what tools need to be in place so that you can get tool orders and things running. But the big issue we had was the machine manufacturer had recommendations on a controller, and they had recommendations on, the spindle based on their experience, and also with tool holders. And they said, well, they've sold a number of these machines. These are the machines that you need to use to make the process work. And the facilities engineers decided that no, they were going to do something different. So anyway, that created, again, you don't follow the manufacturer's recommendations. Obviously there's two sides of it. The marketing people tell you everything will be great when you buy it. But the other part of it is, these companies have experience with with integrating machine components and delivering a machine, and it's probably in your best interest to follow that. So that was quite an experience. Then in the early 2000s, we were involved in creating models for manufacturing configurations. Boeing had shut down the factories, and the factories in Long Beach were shut down, and the work went outside, and we're having because the engineering definition is one thing, but your manufacturing configuration may be a little bit different. So we had to come up with a concept and create models for that. The next piece I worked on was something called the Universal Splice Machine, and it was portable automation that went to the aircraft, where I'll refer to in this as monument tooling and monument automation. That's where you take the product to the tool. With portable automation, you take the tool to the product. So that was another very difficult transaction in making that work, because it had been through R&D and it worked well in R&D, but production is not R&D, so it became a little bit of a challenge. And then another major thing I worked on was redesigning stretch form tools using finite element method and finite element analysis. So that technology wasn't available when the program started, but a lot of our problems, particularly with shape, were related to the fact that there's different residual stresses when you form the product, and you need to, when you have access to that technology, you need to be able to use that technology to find your tooling. So that, I spent a number of years working on that, and what I learned as time went on is that project management becomes an important part of technology integration, particularly having a good project team. So some of the hard lessons that were learned earlier were based on the people that started the projects didn't have robust enough teams. And then as time went on, I was, based on my work, my last 5 or 6 years at Boeing, I was accepted into the technical fellowship. So that's something I'm very proud of, but it was a lot of hard work.
I would expect. And so you've been involved and have a lot of great practical knowledge of these projects, and we're going to talk more about that. But I was also keen that you share with the people who are going to be watching what the benefits were that came from the work that you had done. So do you have examples of positive technological change that worked and gave a benefit to the company?
Yeah, absolutely. Some of the projects that I spoke of initially, when they were successfully integrated, there was a tremendous savings, and we eliminated a lot of tooling. So when you eliminate physical tooling, you eliminate calibration and you eliminate storage, and now it's easier for you to make changes when you're working in a digital world than it is if you're working in a physical world. So kind of a little background, even the C-17, most of the shape of the aircraft was defined by tooling masters, and the tooling masters were made from loft data, and they are made of aluminum contour boards and plaster, and there's also tooling holes. So they're very complicated, but they take up a lot of space, and there's a lot of maintenance to them. So you have to protect them, you have to have a place to put them, and then if you have an issue with the tool, in many cases you have to go back to the master. So making everything digital certainly improved the quality. It allowed us to make changes more rapidly. So when we needed to make configuration changes, or if engineering wanted to make a change, it was much easier to integrate it into that process. And we also, on the Torrey's mill, the 5-axis CNC mill, we did on-machine inspection, which had never been done at McDonnell Douglas on a product that was of that size. And we were able to get real-time SPC data and run that into a computer and have people analyze it. I think as time went on, lessons were learned that you really need to have more of that information made available to the machine operators so that they can see what's going on. But in the beginning, it was quite an accomplishment to do the on-machine inspection and to have these inspection reports. And then as you ran through problems, because we would build a product in Long Beach and it would go to either St. Louis, Missouri or Macon, Georgia, they would do a sub-assembly build-up, and then they would ship it back to us, and then we'd do the big sections, put the big sections together. So it was good to have that data. If you started to run into problems in assembly, I can go back and pull up a report, and it will give me an indication of, is it a part problem or is it a tooling problem? Because sometimes you have tooling issues. So there were great benefits there. And then the ergonomic benefits of not having people. Most of our fastener installations were titanium interference fit fasteners, and people doing that by hand. And there was a number of hand operations. Over time, that wears the body down. And then sometimes as you move into the assemblies, the access to the area is very difficult. So the automation certainly provided a lot of benefits. It reduced costs, and then at the same time, obviously your headcount goes down, but that's something we'll probably talk about later.
Thank you. And so many of the projects that you were involved in gave good benefits. We also know that a lot of technology projects fail, and I was keen to hear what you thought the main reasons for this were, what might be done to avoid them, and what your experience was there.
Yeah, so, the reasons for failing are numerous. I think one perfect pitfall is for the upper management to fall into the trap of the OEM's marketing proposal. And of course, the people coming in are marketing the tool, and they'll tell you what it can do, and they'll lead you to believe, particularly if you have no hands-on manufacturing knowledge, it's just plug and play. It's like a toaster. You bring it in, you plug it in, you put the toast in it, you set the dial, and off you go. But it doesn't always work out that way. And there's also a tremendous amount of costs if you don't have a good project plan that are not quite obvious to people. So buying the machine is one thing, but with our case, we had to create engineering models, we had to create programs, we had to create process specifications, and all of this is time consuming and there's costs associated with it. So somebody may get the idea that I'll sell you this $5 million machine and it will increase productivity so that it pays for itself in 3 or 4 years. Then the project itself may end up running for $12 or $15 million. And then people just get, how come, what's going on? So that's one issue. Another issue that I'd like to talk about a little bit is problems you can have when you're dealing with foreign manufacturers is technology transfer, and particularly licensing and export requirements. So a lot of people overlook this. There's in the United States, we have EAR, which is run by the Commerce Department, and ITAR, which is run by the Department of Defense. And there are regulations, there are export regulations, technology regulations that you can't do business with certain companies. And that also includes the subcontractors. So if you subcontract work to Italy and they subcontract work to a country like Sudan, then that's going to become an issue and you're responsible for it. But one good example I would go over briefly was a problem that McDonnell Douglas had in the 90s with a program called a trunkliner program. So McDonnell Douglas had been involved with China for years, and China wanted to build their own aircraft. So we were selling them aircraft. They came up with a project, an agreement, that we would build 20 aircraft and China would build 40 aircraft, and we'd send them all the parts and all the tools and all the technology they needed to do that. And they went through the Commerce Department, and they were successful in getting a license and we had shut down a factory in Columbus, Ohio, that at one time had built Minuteman rockets. Rockwell had it. It built the B-1 bomber. There were a lot of C-17 parts that were being built in it. They started taking these machines and shipping them to China. And the Defense Department caught on to this, and they're saying, well, you need a technology license approved by us in order for you to send these machines over to China, because we say that it's proprietary military technology that you're providing to China. So on the Commerce Department side, you're free to deal with China pretty much. There's not a lot of restrictions, but on the Defense Department side, you can't deal with China at all. So the machines were impounded, and then about a 2-year process went on where the whole project was put on hold. China was going to cancel the project, and part of the way I became involved in it was we needed to build a case to prove that 5-axis CNC machines were not exclusively military technology, because that's the way the DoD looked at it. So again, somebody ramrodded this license through the Commerce Department, and it created tremendous headaches and a lot of costs. And at one point in time, China was just going to cancel the whole contract, which would have been, because they had taken these kits of metals and fasteners and parts and everything and shipped them to China so that China could build them. So it was a great example of, if you're dealing internally in your own country, it's not an issue. But when you're dealing with foreign suppliers, particularly your ability to transfer data or tooling needs to have a license. We had a supplier in Canada that was building some composite parts for us on the C-17. And in order for me to send master tools in there to reset their regular tools, I had to get a license. So even to deal with Canada, I had to have a license. Canada it had to have a license so it could go back and forth. And some people would think, oh, well, Canada, they're our friends. We'll just go to Canada and we'll bring them all this information. So that is another thing. I think the other area is not having laid out a good plan with a good project team from the very beginning of the project. And also to have a good executive sponsor, somebody who can get you additional funds, support for additional funds, or support for additional headcount as you're working through the project. So if you don't lay it out and do a good job and understand everything that's involved, and that involves, and you have to work with a lot of different groups. And you have to ask them, if I'm going to do this, what support do I need from you? And then, like, if I go to design engineering, the whole design engineering will tell me how many hours they need. If you miss that, then it will slow the project down, and then it will increase your costs. And then you have to go back to a change board and say, oh, well, I told you I could do this project for $7 million, but now I need another $3 million. And then the beatings begin. And eventually, depending on how far you are into the project, you will probably get the money, but the next time you go to that board, they're going to look at you like, oh, here's the guy that had the big cost overrun. So now you have another project, and the scrutiny is going to be far different.
Interesting. So you talked a little bit about dealing with technology vendors and the promises that they might make about the equipment, but could you talk a bit more about the role that vendors can play in technological change and digital transformation, and the advice that you might have for companies that are working with vendors and how they can do that more effectively?
Well, my position has always been the reason they're in that business is because they understand that business. And you will always be dealing with people in your organizations who, I'm not saying that they're not knowledgeable, but if you're building the machine and you're doing the machine integration and you're doing all this work, whatever this technology is, they're the ones that have the expertise. So I believe it's in your best interest to follow their advice. I mean, particularly from the engineering side, I don't think they're going to, because some people think, oh, they're just trying to sell you something so they can make money. But I think as an engineer, you have an understanding of the technology and the integration. I think it's critically important that you listen to them and that you follow their recommendations. And one area that comes up as a problem is contracts. They will install a system and it'll have an operating system in it. So that operating system is current today. 5 years from now, that operating system may be obsolete. So there are agreements you can make with the suppliers where they will continue to upgrade you for a number of years, and then you can renew that contract. And when they make those changes, they will come in under that contract and they will upgrade the equipment for you. Otherwise, to use an old example, you could have a machine that's running on Windows 98, and now all of a sudden you need to have parts for it, and you're going on eBay trying to find junk parts because nobody has this anymore. Microsoft doesn't support that operating system anymore. The components that go in it are pretty much obsolete. And another area is critical spares. So particularly with complicated machines, experienced machine vendors know what spares you should have on hand. And some of it has to do with the lead time. So if you don't take a certain component for a spare, and then you go and order it from them, it may take them 3 months to get that, right? So now that's could be 3 months downtime for you and your equipment. So I think that needs to be looked at. We ran into issues where our facilities guys, they didn't need anybody's help. And then we ran into situations where there were problems with the machines and we experienced downtime. And, so I think it's important, and it's important to work with them. So we would go and would have buy-offs on, a 50% buy-off. We would want a technology demonstration at the vendor. So that would be part of the testing. That would be part of the whole purchase. But you would do so we call it a design review. Do a 50% design review, an 80% design review, and that may. And with us, we were purchasing machines from Spain and Germany, so you'd have to send a team over there. So that's another thing that you're going to have to budget for. It's not you're going to send a team to Germany for 2 weeks. There's going to be an expense involved in it. So does that help answer your question?
I think it does very well, and thank you. So as you have introduced technological change, trying to do that at the same time as having operations continue is an area where we often see challenges. How can continuing operations and change be managed together?
And that's where you need to have an excellent partnership with the manufacturing side of the house. In some cases, you're in a company where everybody's on the same site and you're just walking down the hallway to talk to people. Some of the projects that I worked on, I'm dealing with a company that has numerous facilities in the United States, and we have international suppliers. When you're going to install technology, and I did a lot with machines, so I'll always refer back to machines, there's a certain amount of construction and disruption that could happen. And you have to build a machine foundation, wiring has to be put in, permits have to be gained, and production needs to understand what the impact is going to be to them, the disruption impact. And then you need to be working very closely with them on a schedule. So sometimes the machine manufacturer may have everything ready to ship in May, but production really isn't ready to do this incorporation until in June. So that would be a situation where you could have the equipment delivered, but don't have the OEM send their engineers over and be sitting around for 2 or 3 weeks because somebody's finishing a foundation or they're running electrical. And also understand that you have a normal production process, and now when you're going to be going in doing construction and you're going to be doing machine building or you're going to be doing technology integration, there is a disruption factor there. And if you're not working very closely with your manufacturing counterparts and there's transparency, then that's going to create that's going to create friction between you and your own people, because they're going to say, well, Ron, you told me this machine was coming in here, but you didn't tell me all this other stuff was going on. Because, it's not, in all these organizations, it's not one person that's making the decisions. So that, I think, is very important. And then the other part of it is, preparing the people for the technology. So there's training and there's things that are involved. And also, if we speak of, in many cases with automation, particularly if you're working with union or bargaining unit people, you're going to come in, and part of the cost savings is reducing physical heads. So the physical heads, where are they going to go? Are they going to be retrained? Can you retrain them? Sometimes there's job classification issues where you can't do that. We had a project where the people who did the work were on hand routers and drilling, so their technology skills were on a lower level. The people that were required to run a machine with a controller and, a complicated machine, they were NC machinists. So our partners supposedly had this all worked out. They had there weren't going to be any issues. When it came time to do the machine installation, we've got 3 guys that, hand drill and hand route, and they're sitting around the machine, and they had to bring in a manager to run the machine, because the other union, they said, well, if we cross-train these people, they have more seniority than we do, so all we're going to do, if we cross-train them, we're going to be laid off. So, I'm not going to train somebody to take my job. And then the other piece of it is, the people, obviously, they may need training in another area. Even coming in, you may have people in a certain skill code that the technology that you're bringing in now is something they've never dealt with. So, there's training and there's processes and procedures.
Absolutely. So you've talked a lot there about the changes and their impact on employees. And so maybe we should go on and talk about the impact on operations support services like maintenance and engineering. What's the impact there in digital transformation?
So in digital transformation, if you have maintenance people and you have facilities people, they're going to need training. In some cases, companies don't have that, so you're going to need to contract it. So you really have to understand what position are you in. And again, that's part of your team that's working with the OEM, the person you're buying the equipment from. You need to have your facilities or maintenance people communicating with them so that they understand what's coming and how it works. Yeah, that can create a huge headache. And the other part of it is sometimes you'll reduce headcount in one labor group, but it may facilitate the need for you to hire another engineer or quality engineer to support this piece of technology. So those are things that also you kind of really got to look at the broad picture, and having these groups involved and giving them the lay of the land, what it's going to be. They need to be involved, and they need to have an understanding. So in a lot of cases, they're going to be the ones that make that determination. But we did run into problems where we had to hire 2 quality engineers to do programming for programs for a machine, because the other quality engineers they had didn't have the background. It was different type of software application that they were working with, and that was something that was unforeseen. But again, what it does is now if you decide, we have a production commitment date of the 1st of June, and you find out in the 3rd week of May that you don't have the right support, then that creates headaches too. So it's quite a few pieces involved, and I think the technology integration is easier with a smaller company, but then at the same time you still have to be able to identify how you can support this technology, and are you going to hire people to do it, or are you going to contract people to do it? You need to have a clear understanding of that from day one, because I really believe that Murphy's Law, anything that's possible that can go wrong can go wrong. And in my experience, he was an optimist. because things will happen. And, you know, particularly in the business I was in, where we've got aircraft moving from position to position on certain dates. And if you shut that line down, there's a huge impact. And sometimes if you're missing critical pieces, you can't move from one position to the next position. So these become the cardinal sins. If it all points back to you, then, you know, you've got a lot of issues to deal with. But again, it's being transparent, having a good project plan, getting everybody involved, letting everybody know what's going on. And sometimes, if you can, I think it's a great idea to ask the OEM for the name of a customer that's, you know, somewhere in your area, where you can go talk to the customer and ask the customer, okay, what were your issues? You know, you purchased this machine, and what were the unforeseen things that you ran into?
Okay. So you're talking about the need for there to be involvement of people from many different areas inside the organization, both in terms of understanding what their role might be during the implementation and after, but also in terms of, you know, getting their knowledge and ideas around what you might be doing. I'm interested in how integration issues might be dealt with, how a change in one department might impact another area. For example, a change in technology and sales may be influencing operations. Would you be able to talk about that a little bit?
Yes. One of this $100 million project that McDonnell Douglas got involved with the DoD, they decided to go out and purchase a very sophisticated assembly machine, a broche. It's a ring riveter, frame riveter. So this machine is very sophisticated, and most of the work is done on contour boards, and the machine is up in the air. I'll send you a picture of it later to give you an idea. So people don't get on this machine. There is no manual intervention when this machine is running. But the parts that you put in place in that assembly all have to have a certain configuration, so that, you know, now we used to call it determinate assembly or part-to-part assembly. If I'm going to put this together on a bed and then raise the bed to run it, it's almost like an erector set, but I've got to be able to pin these things together. Those become, that's your upstream process. Now you have to go back into the downstream, and there's a lot of corrections that you have to make in the downstream in order to have the product that's acceptable to go in there. That's one piece. So when you talk about sales, you know, your sales force may go out and make some unrealistic promises to customers, and that's certainly a big headache, where they go out and, you know, I don't think they're trying to be deceptive, but maybe they're overly optimistic. And then when the product goes to your customer and it doesn't meet those expectations, then that creates another series of issues altogether. And sometimes even with your, you know, I mean, it could be damaging to your product. We did with, talk about a McDonnell Douglas product, the MD-11. One of the big selling points on the MD-11 was its extended range. So there were changes that were made. The aircraft was upgraded from a DC-10, but there were range predictions that were made that were like 1,800 miles, you know, on a load of fuel, that allowed the aircraft, the people that were buying the aircraft, to say, okay, well, I'm going to use this MD-11 on this route now because I don't have to stop and refuel. And one of the big downfalls of that aircraft was that performance was never met. So there were customers who purchased the aircraft and sold the aircraft. There were other customers who, when they found out that there were these range problems, then they changed their order. So that would be a situation where your sales department went out and, you know, they made some promises about performance and cost savings, and it turned out that the product that you delivered didn't fit that.
Makes sense. And I've seen similar things elsewhere. I've just got two further questions. The first is, how can workers themselves be better prepared for technology-based change? What should they do to improve their job security and job quality in the midst of technological change?
So technology is changing so rapidly that, it was when you and I were young, you went to school and you got a degree and you went out and worked for a company, and, maybe the expectation was at that time you would stay with that company doing that job until you retired. Well, now we see whole technological innovations becoming obsolete in 20, 25 years. So I think two things. One is the expectation of your learning and training is going to be, it's going to be a lifetime thing now. It's not going to school and then, taking a class here and there. But I think the foundation of your education is important so that you can be flexible. So, the flexibility and the courses that you take, and you have to try to think ahead as to, right now, these are the courses I'm going to take for this technology. But you want to have a solid background, because in 10 years, if this is gone, you may have to learn a whole new series of technologies. And a lot of it has to do with the, I think it's more broad-based. So if somebody gets focused, to use an old example, like, well, I'm going to be a nuclear power engineer. So it was at one time, you're going to be a nuclear power engineer. That requires a whole series of courses and training that you take that's very focused on that one thing. And, there was a time when it's like, okay, that's the future is going to be nuclear power generation. Well, now, nuclear power generation, I think the big part of it now is how do we take it apart and dispose of it? So it pretty much disappeared. So if your whole focus was that narrow on that one area, it may be difficult for you to go into other areas, and so I think the courses that you take, and also the expectation of, okay, I'm through with school now, but I think learning is going to be ongoing because things are changing and nobody can predict how long they're going to last. If we look at the Industrial Revolution, how long certain aspects of it, like, the second phase of the Industrial Revolution went on for over 100 years. The third phase was about 30 years. Now we're going into Industry 4.0, and people are already working on Industry 5.0. But the other piece of it, too, is being an engineer is not, every company is not going to go out and invest in all brand new equipment. So you have great developments in Industry 4.0, additive 3D printing, things like that. There's still other technologies that you're going to have to support. So you need to have an understanding of that. Automation isn't going to go away. Automation is probably going to change. You're going to see more robotics, but working with controllers and PLCs and those things, that's something that's going to be around for a while. So you want to be prepared to have the right tools to move into a position to support new technology. But at the same time, just the way business works, companies aren't just going to throw out all their machines and buy all brand new ones. So if you're in a larger corporation, like I talk about aerospace, you're dealing with integration over a number of years. So you have to have an understanding of how that works and how you're going to be able to support that. I was in production engineering, so I was more attached to the production process flows, or if there was a problem, I'd get called out to the floor. Other people are in design in other areas where they don't have that, they don't have that accessibility. You may be designing in the state of Washington and building in Alabama. That's not unheard of. But again, it's the flexibility. The learning is going to go on. We have no control and we have no understanding on how quickly technology is going to change. So we need to be prepared for that going forward. But at the same time, we need to have good experience to support the other things that are already in place.
Solid advice as far as people's skills go. My last question is around any other advice that you'd want to give engineers on digital transformation, considering all the things we've talked about today. Is there anything else that you'd want to say to people who are engineers now about what they should do with digital transformation?
Well, I think it's something that's critically important that you understand. I think the future of technology-driven change is also like an amusement park ride. So you're going to get on the ride, you better make sure you're strapped in, because there are going to be situations where things are going to change very rapidly. But I believe that it's very important to, you don't need to become an expert in any of these areas, but you need to have a functional understanding. So something that I did that today, when I had a notebook, and in my notebook, I had notebooks of our processes, and I also had a list of contacts of the people in certain areas. These were my trusted people if I had issues. If I had a problem with hot forming titanium, which is something that not a lot of people know that much about, today you'd probably have it on a thumb drive. But we talk about, coming together and networking. And there's one level of networking where you go out and you have a couple of drinks and you talk to people, and Bob's a good guy. If I need another job, I can go talk to Bob. There's also the networking, your professional and technical networking, that's critically important to you in your career. Because in some things, I worked in aerospace. It makes me laugh because sometimes somebody says, well, here's Ron Gill. He's an expert on aerospace. I'm not there's nobody that's an expert on aerospace because it's too complicated. I'm certainly very knowledgeable in areas of aerospace, in certain areas, but you can't say that one person, you wouldn't have enough time to learn all these different systems and processes. But it's important for you, if you may work in these areas or run into problems with them, that you have a good list of contacts, or you have a good set of notes about, if I work with this certain alloy, these are issues that happen with this type of an alloy, particularly in production. So if you look at the additive process, it's great, but everything isn't going to turn overnight to additive. And there's also sometimes people will go out and make commitments based on a technology that they know nothing about, and that can cause problems with customers. I think I had shared with you, we had a military program where we had a wing spar, and it had fatigue life, and based on the fatigue life, the parts had to be replaced. The supplier who did it went out of business. Nobody got there, because everybody, you can look at drawings and models, but a lot of times there's proprietary ways on how you make that work. And somebody made the commitment to the customer that they would produce that in additive and they'd have all their parts in 6 months. And then people had to go to the customer and say, no, that can't be done. It's impossible. That really upset people, but it's like, they said, but you're a VP. Well, my VP was, they're really trying to help, but they didn't have an understanding of that. So if you were talking about going into additive and you're not into additive or 3D printing, and you had a part you wanted to put in that process, it would be really good if you had somebody you could talk to where you said, I have this part, and I can send you a model of it so you can look at it. This is the alloy, and this is the temper that I need. Is it possible to be done? Because you might look at it and say, gee, they did make a part like this, down the street. How come I can't make a part like that? So I do believe that it's very important that when you network is to have this list of people that you can talk to. That's even in school, like you're the professor, sometimes it's go back to the professor. I have an MBA from UC Irvine, and there were times when I ran into problems that were business related, and it's like, oh, okay, well, call up the professor and ask him, what do you think? So I do believe that that's very important. Technology is changing. You have to try to be prepared for it, but at the same time, you need to have a good list of contacts, people that you have faith in. If I call you up and ask you a question, if I call Peter up and ask him a question on this, I really believe that, Peter's a good guy and he's going to give me the right advice, rather than just cold calling somebody and just hoping whatever they're telling you is going to work.
Very valuable. Thank you for providing that advice to people. We've covered all our questions, Ron. Thanks for taking the time to go through them.
All right.